Neptune is like a celestial paint swatch, a stunning royal blue that demands attention. The eighth planet in the solar system, it is one half of the ice giant system, the other half being Uranus, and among the most mysterious worlds circling our Sunday mental floss spoke to Mark Hofstadter, a planetary scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, to learn more about this lesser-known planet. Here are a few things you might not know. 1. It has 6 rings and 14 moons, one of which has geysers blasting into space. Neptune is about 30 times farther than we are from the Sun, 2.8 billion miles to our 93 million miles, the farthest in the solar system, aside from the dwarf planets. Its effective temperature, according to NASA, is -353 degrees Fahrenheit. Its mass is 17.1 times that of Earth, and it's big, but not Jupiter big, with an equatorial radius of 15,300 miles. Neptune is circled by 6 rings and has 14 moons, one of which is geologically active and blasting geysers into space. Plumes are ideal for sampling. Rather than building a lander, you can just fly a science spacecraft right through them. A Neptunian day is short, at 16.11 hours long, but its years are a different story. 2. In 2011, humanity marked Neptune's first birthday. It is impossible to see Neptune with the naked eye. Galileo first recorded its existence with his telescope, though he identified it as a star, misled by its slow orbit. In the 19th century, astronomers noticed an aberration in the orbit of Uranus, and Urbain-Joseph Leverrier, a French mathematician, went to work on the problem. With a pen and paper, he worked out not only the existence of a planet, but also its mass and position. In 1846, Johann Gottfried Galle made the observation at the request of Leverrier, and sure enough, found a planet. A couple of weeks later, he also observed Triton, Neptune's largest moon. It took 165 years for a full Neptunian year to elapse. That's why we celebrated Neptune's first birthday in 2011. 3. It's called an ice giant. But it doesn't have much ice. Hofstadter tells Mental Floss that until the Voyager 2 spacecraft visited Neptune and Uranus in the late 1980s, the two planets were thought to be small Jupiters. It turns out they are fundamentally different than Jupiter, he says. They are around 2/3 water by mass, and then they have some rock and an atmosphere of hydrogen and helium. The ice in ice giants refers to their formation in the interstellar medium. When modeling the formation of the solar system, things are more or less sorted into 3 categories: gas, rock, or ice, says Hofstadter. In interstellar space, helium or hydrogen will not exist as a solid or liquid, so they are the gases. They form planets like Jupiter. Silicates and irons, meanwhile, are solid, and exist as dust particles blown out from such things as supernovae. They form places like Earth. Then there are in-between molecules, such as water, methane, or ammonia. Depending on the local temperatures and pressure, they might be water vapor or solid ice. Those are called, you guessed it, the ices. When planetary scientists found that, wow, Neptune and Uranus seem to be mostly stuff like water and methane, they called them ice giants, Hofstadter explains. But the name is misleading, because today there is very little ice in those planets. When they formed, the water was probably coming in as ice, he says. Now, however, it's hot enough in the interior that almost all of the water there is liquid. Neptune's blue hue? That's due to the methane in its atmosphere. 4. It has a solid core surrounded by an ocean. The rest is a mystery. But not liquid water like you find on Earth. The interior structures of Neptune and Uranus are among the biggest questions facing planetary scientists today. The conventional thinking is that there is a rocky core at each of their centers, surrounded by an extensive region of ocean. A hydrogen and helium atmosphere comprises the outer layer. There's a lot of atmosphere to get through before you hit the ocean, says Hofstadter. It is deep enough that it is under extremely high pressure and temperatures. It is probably a highly reactive ionic ocean. The water exists in what is called a supercritical state. It doesn't behave in the same way that water in our oceans behave. It's probably conducting and has a lot of free electrons in it. 5. Neptune's formation is one of the great celestial unknowns. When planets form, solids first come together. When a solid ball gets big enough, it can gravitationally trap gas, and there's a lot more gas around than there is rock. Hydrogen is the most abundant thing in the universe. Once you get a rocky core that's big enough to trap gas, a planet can grow very rapidly and can grow very big, says Hofstadter. In the inner solar system, where there was not as much gas, or ices were not solid, you got the terrestrial planets. In the outer solar system, where there was rock and solid ice, large cores formed quickly and started sucking up all the gas around them. That's how you get monster planets like Jupiter and Saturn. How this relates to Neptune, and Uranus, a star, as it is forming, has a phase during which it has a tremendously strong stellar wind and effectively blows away all the gas. If Jupiter and Saturn had been in an environment with an endless supply of gas, they would have grown big enough to eventually become stars, says Hofstadter. But the idea is, the sun kind of turned on and blew away all the gas, and Jupiter and Saturn had their growth cut off. Neptune and Uranus have large cores big enough to trap gas. So the question is, why didn't they become like Jupiter and Saturn? Jupiter and Saturn are 80% gas, by mass. Why are Uranus and Neptune something like 10% gas? Why didn't they trap more? The first theory involves luck. The idea is, well, for Uranus and Neptune, their cores got big enough to trap gas precisely at the time when the sun started blowing away all the gas. There wasn't enough, and they couldn't trap more, Hofstadter says. It's possible that could happen once or perhaps twice in a solar system's formation, explaining Uranus and Neptune. But the study of exoplanets have upended this thinking. When you look around in our galaxy and see how many ice giants there are, it's hard to believe that every solar system out there was lucky enough to have planets forming large cores just as their stars started blowing away all the gas, he points out. So this is a fundamental question: how do ice giants form? And we don't understand. 6. Neptune's rings are clumpy. Unlike the rings of Saturn, the 6 Neptunian rings are thin, young, and dark. Their color is due to their composition, radiation-processed organic material. One of the rings features 3 thick, distinct clumps named Liberty, Equality, and Fraternity. The clumps are something of a mystery. The laws of physics dictate that they should be spread out evenly, as you see at Uranus, but there they are, little lumps in space. Before Voyager 2 visited, only the clumps were visible, and were called arcs, part of an incomplete ring. The most likely cause for the ring irregularity is gravitational meddling by the moon Galatea. 7. More about that moon with geysers. Triton, Neptune's largest moon, is thought to be something like Pluto, an object from the Kuiper belt, the ring of icy bodies beyond Neptune. It happened to be gravitationally captured by Neptune, says Hofstadter. It is a fascinating object to study because it's a Kuiper belt object, but it's also interesting because it is active. We see a lot of geology on Triton just like we see on Pluto. When Voyager flew by in just a few minutes, it happened to see geysers spouting off. When Triton was captured into orbit around Neptune, you can see it circling the planet in the video above. It caused all the native Neptunian satellites to be destroyed. They either impacted Neptune and were absorbed, or they were ejected from the Neptunian system. 8. It has a great dark spot. Just as Jupiter has a great red spot, Neptune has a great dark spot. They are both anticyclonic storms, though while Jupiter's spot is centuries old, Neptune's spot is short-lived. It seems to come and go. Notably, the great dark spot even generated stunning white clouds over Neptune, much in the way that cirrus clouds form from cyclones on Earth. 9. We've been there once but want to go back. Only one spacecraft has visited Neptune, Voyager 2, in 1989. The photo of Neptune at top was taken during that mission. In fact, it's likely the source of any image of Neptune you've ever seen. Pretty much everything scientists know about the world comes from that flyby, and from telescopic observation. The James Webb Space Telescope PDF, which launches in 2019, will unlock new ice giant science, including mapping cloud structures, observing auroras, and studying post-impact atmospheric dynamics. Some things, however, such as a detailed atmospheric composition or a study of its satellites, can only be done by a spacecraft at the system. Planetary scientists are today developing flagship-class missions to visit both Neptune and Uranus. An ice giant's mission is considered a top priority of the planetary science community, after a Mars sample return mission and a Europa orbiter. Mars 2020, which launches in its namesake year, is a sample caching rover. Returning those samples to Earth awaits a future mission. Meanwhile, the Europa Clipper was approved by NASA and is well into development. That puts Neptune and Uranus next in line. A mission to these planets would have to launch no later than 2034, lest their orbits place them beyond easy reach.